Okay, class, today we are going to be working on drawing polygons on a coordinate plane, which might sound kind of scary, but trust me, it's not. But first what we'll do is we will review. So at the beginning of the week, we worked on composing and decomposing figures in order to find the surface area. Can someone tell me what the surface area is? Like, give me an example of what we'd use it for. Or an example of something you would. Okay, yes, like we use paper, right? So paper would be surface area. It doesn't have very much thickness, right? It's just taking up that amount of space on a flat surface, right? The next day we talked about volume, and sometime what the difference between our surface area and volume was. Yes, volume has thickness, like these figures here. So like your phone, did anyone try and figure out the volume of their cell phone? Yeah? Yeah. Just things like that. We talked about how this could be like a can of soup, right? So let's review our area. So here I have two triangles, and I compose them into a rectangle, okay? And these are our sides. So we're putting two figures together and composing them, and then what is our formula for a rectangle? Is it this? This is for a triangle. So what we can do here is we can find the length of this, or the area of this triangle, right? But if we're putting them together, we're just going to do the length times the width. So we're going to have A equals length times width, and the length is 8, and the width is 4, which equals 32. Now, if we were to compose, if we were to decompose and split the rectangle into two triangles like this, so what we just did was compose them by putting them together, right? We got rid of that line and put them together. Then if we want to decompose to find half of the area, one of these triangles, now we're going to use this formula up here, which is half times, what's the B stand for? Base times the height, okay? So for this one, it's going to be A equals half times, we'll put our base here, times our base times our height. So first, what is 4 times half? 2 times 8. Because if we remember, if we're multiplying, it doesn't matter what order we multiply this in, right? It's going to be the same thing. If we were to multiply the 8 times the half first, or the 8 times the 4 first, it would still come out the same. So we multiply these two first, and we got 2. Now we have 2 times 8, which is 16. So then that is the area of this triangle. Now something cool, how we just composed everything, if we were to multiply this by 2, we'd get the area of this whole thing, right? Of this whole rectangle, because our length times our width is half base times height. Alright, so now let's move on to this one. Here we have this side length and we have this side length. So we can do this a couple different ways to find the area of all of it. If we just want this, all we're going to have to do is take the 2 times the 4, right? Which is, what's 2 times 4? 8. And now if I want this, if these are equal, I can either multiply this by 2 to get 16, or I can start from the beginning, and if this is 2, that means this is 2, so that our length is 4, and this is 4. What is 4 times 4? 16. If we were to get rid of this line, get rid of these, it becomes a square, right? And what's our formula for a square? Our formula to find the area of a square is S squared, right? A equals S squared. Because 4 squared, 4 times 4, 16. to volume. Oh, I have this one right here quick. Do you guys remember figuring this one out, how we figured this area out? We can compose this by drawing an imaginary line, find the area of this rectangle, which is length times width. So we have A equals length times width. So we have 6 times 8, which is 48, but that includes this. So then we have to find the area of this small area and then subtract that from our big one, right? So 4 times 2 is length times width, 8. So our answer would be 40. So the area of this is 40. All right, so now let's move on to our volume. For our volume, we said that it has a thickness to it, right? It's filled with something, or it has, it takes up more space than just a sheet of paper, right? Like our Chromebooks. They are the same shape as paper, right? It might be a rectangle, but it takes up more space because of the volume. For our volume for our right triangle, we're going to do length times width times height. So it's close to area. All we do is we add the height as well. So we have our length here. So we'll have our volume equals our length times our width times our height, which is then going to be 4 times 6, we'll say 24, times 8, it's going to be, carry the 3, 8 times 2, good. Our volume for this is 192. Good. Y'all got that one? Yes? Any questions about this one? Or we understand? Okay, good. So let's go on to volume of a sphere, right? Our right sphere, right? What does this B mean in comparison to this B? This is base, and this is our base, our circle, right? We're going to take our area of our circle and multiply that by our height. So if our radius is 3, what is going to be our formula for this figure? It's going to be V equals, then this radius is 3. How do we find the area of a circle? Pi times r squared. So we have pi r squared. What would be our radius in this formula? In this figure? 3. Good. 3 squared. 3 times 3? 9. So we have 9 pi. So we're going to move that up to this formula, this equation, and we're going to multiply 9 pi. That's a funky looking pi, isn't it? Times what? Our height. Now is our height this length right here? It's the middle length. It's from the top to the bottom, right? What is, if we distribute the 6 into 9 pi, we get 6 times 9, which is 54 pi. So the volume of this is 54 pi. All right, so now what we're going to do is we're going to move on to today's, which is drawing polygons on a coordinate plane. So, can someone tell me what a polygon is? A polygon is a figure with straight sides. It's two-dimensional. It's like your paper. It's like your piece of paper, like when we're doing an area. So this right here would not be a polygon because it's not just straight sides, and it cannot be drawn on here in 2 dimension, right? This is a polygon. Is this a polygon? No. It just has straight sides, like a piece of paper. So that's what a polygon is. So we're going to be drawing polygons. So we have triangles, circles, squares, parallelograms, trapezoids, that kind of stuff. And this is our coordinate plane. This line right here is the x-axis, and this right here is the y-axis. When we are graphing, we always start at the middle and move out in either direction. So this, if you remember your small graph we used, we just had this and we worked on the number line. This is like the number line, except we've added another line here. Okay, so this is your x-axis and this is your y. When you see something like this, if you see a number, I'll make it a little bigger. If you see something like this with a number, comma, another number in parentheses, this is telling you to graph it on a plane. You're looking for two answers, okay? Because the answer here is not 3. We're not going to just go 3, 3. We're not going to just go put our point on a 3. We're going to put our point on the 3, 4, okay? What you have to remember is that our x always goes before our y. So when you see when you're given a point like this is our x and this is our y. You can remember this because x comes before y in the alphabet, right? So x comes before y, our x is this one, our y is up and down, and our x always goes first in the expression. So we are going to use points and plot them on our plane here to find polygons, okay? So you'll need a ruler. We'll do a couple of examples first. I have 2 examples here. And then I'll have you work on it your own, but you'll need rulers because we want straight lines. Remember, that's what a polygon is, it has straight lines. So first thing we do, these are our set of points. We go to the first one. The first one's -2, 2. So the first thing we do is look at our -2, our first number. That is the x or the y? The x. Good. So we're going to go to -2. This is 0. Now we're going to count backwards this way to -2. So right here, right there is our -2. Our y is 2, which is right here, right? 1, 2. We're going to come up this way, come over this way, and our point is right there. That is 2, -2. Okay? Now we go to our next one right here. Our first number is what? The y or the x. It's going to be on the x-axis. And it's a 2. So am I going to go here? No. Am I going to go on this point? No. I'm going to start here on this 2. We'll go 0, 1, 2, because we're on the x-axis. This is the 2 on the x-axis. Then we look at our next point, which this one's on our y. So we're going to go up to 2, 2. So we have our second point. And remember, we're drawing a polygon, so this is going to make a shape, and we're going to connect all of our points when we're done and try and figure out what shape it is. All right? So let's go to our next one. Our next point, we have a -2. Am I going to start this point on our x-axis or our y? The first number, -2. Right, on our x. So I'm going to start at 0 and go 1, 2 to the left, right? Because that's where our negative numbers are. And then I'm going to go -2 y on our y. Am I going to go up this way? No, I'm going to go down this way and put our point right there. So for this number, like our number line, we have the right is positive numbers, our left is negative numbers. For our y, up here on the top of 0, this is our middle point right here, 0. The top is positive, the negative is the bottom. So think of this as like, you're going swimming, right? And you're up here above water, but then when you go underneath, you're negative, right? You're underwater, don't have as much air. So now let's look at our last point, and then we can connect all of our points to make a polygon. So we're looking at 2, -2, we're not going up, we're going to go down, -2. Now if we connect these as much as I can without a ruler here, to get a square. Good. So, you might look at this and say, well, why would we ever need to use this? Why would we need to have a plane like this and put a polygon on our plane? Like this can't be used in real life. It can be used in real life. Oh my goodness, math can be used in real life. So picture this as a house, okay? Pretend you have a floor plan. They may try to rearrange their room before. And you have your bed. What shape is your bed? A rectangle. Yep. How about a dresser? Another rectangle. So if you have a graph or a plane like this, right? We could even, to make it look more like a floor, right? Draw a square like this. And you're like, you know what? I want my bed in the center of the room. Where is my dresser going to fit? Well, let's put some points. Say your dresser is this big. You're going to connect them. And you'll know how much room you have between your bed and your bed and your dresser, right? So this can be used in real life. We're going to do one more example. My numbers are erasing here. One more example. We have, our first one is -4, 1. So what's the first thing we're going to do? First thing we're going to do is look at our first number, yep, and go to 0. Is this, oh, I didn't even label these ones. Is this our x-axis, our x line, or is this our x line? Right, this one. So this is x, means this is y. We're going to go -4. We're going to go to the right or the left? The left. Good. 1, 2, 3, 4. So we're right here on our 4. Then we're going to go up 1. So there's our first point. Now we move on to our next one. -4, 6. So we're going to look at this line. We're going to go back to the -4. We're going to go this way to 4. Now we're going to go left to 4, right? Because this is our negatives. 1, 2, 3, 4. And we're going to go, how many are we going to go down? We're going down 6 places, right? Because in the negatives, here's our 6, here's our 4, maybe. There's our second point. Just remember, we're going down, negative. We don't want to be in the negatives. We want to go down. We go up, right? Positive. Our next point is 1, -4. So we're going to go start at 0, move over 1 on our x, because our x always goes first, and then go up -4, right? No, we're going to go down -4. 1, 2, 3, 4. There's our next point. I'm not sure. What do you guys think this one looks like? What do you think it's going to be? Maybe it's a triangle, right? You have a triangle here. Can't be a triangle with another point, right? And it's definitely not a square. It's not going to be even, right? These are not. Yeah, definitely not. All right, our last point. 1, 4. What are we going to do? We're going to go over 1 and go down 4, up 4. All right, so now let's connect our points. What is that? Anybody? Anybody at all? No? Okay, let's try this. Let's try how that one might be a square, but is it at different angles? Is this like this one? No. It's a parallelogram, right? Because it's slanted, right? We have our two lines here and our two lines here, but they're slanted. Make sense? So what you're going to do is you're going to go through. I have graph paper for you on my desk that you can grab, and then you're going to look at my points, and you're going to, some of them don't have all of the points, so sometimes you're going to have to look at what shape it is. I have a square here, so you have your points, and you need to figure out what the last point is. Here I tell you it's a parallelogram, and you're going to figure out what this point is, right? Remember, for parallelograms, I already erased it, but they're all, the two sides are parallel, they're just slanted, right? So it's a rectangle that has been shifted, right? For this one, I have your points, but you have to tell me what shape it is. So there's a couple like that as well. When you're finished this, go ahead. I don't have another worksheet for you today. You just have to do these 6 problems. Go ahead and open your Chromebooks or study on what we've done this week, because you will have a quiz at the end of the week. Go ahead and open your Chromebooks and work on some of the math games I've given you already. But yeah, if you have any questions, just let me know and we'll work on them together. All right. Okay, so I hope everyone did well on the worksheet. I know there was a couple of problems or a couple questions, and I'm just going to review one more before we go. So let's look at number 3. We're going to work on this shape, okay? So we're going to go -5. So someone tell me where our -5 is. Is it down here? Which number went first? The X, right? Which letter? The X goes first. So we're going -5 and up 3. Should be right there. -5, 2, which will be right here. And then we have 1, up how many? 2. And then our last one is 1 again, up 3. We connect these, connect our points. And what shape is this? A rectangle. It looks kind of funky because our lengths and our widths are so different, but I'm sure there can be a bed that's definitely not proportional like that or something, or maybe a dresser. There you go. Remember that we will have a quiz at the end of the week, so make sure you're working on this. If you have questions, we'll talk again tomorrow about it. We'll review over this some more. And that's all.